The next problem is we have to prove L of t into sin 80 is equal to 2as by s squared plus a squared the whole square, and L of t cos 80 is equal to s squared minus a squared by s squared plus a squared the whole square. Solution. Here we don't have any formula for the combination of t into cos or t into sin, but we have a combination for t into exponential. That is, if we use the exponential, we can use the first shifting property. So in that case, what we are going to do here is both the problems we are going to solve at the same time. That is, we are going to use the exponential term to solve sin and cos. Since we know L of t is equal to, so what is L of t? It is 1 by s squared. Then what is L of t into e power iat? So here it is sin 80 cos 80, so I am going to use exponential of iat. So this, so what is this? This is L of t into cos 80 plus I sin 80. Okay, so let it now L of t e power iat is equal to 1 by, so L of t is 1 by s square. Let me use the first shifting theorem. So if we are going to shift s, what is it? It is s minus a, here is ia, so it is ia the whole square. So now I have shifted s as s minus a here is ia, so it is s minus ia the whole square. So this, I have to separate the real and imaginary part in order to compare with this. So how to separate the real and imaginary part? We can multiply and divide by s plus ia, so that we can avoid I in the denominator. So I am going to multiply and divide by s plus ia. So this is equal to s squared plus 2ias minus a squared by, this is a minus a minus b, and a plus b, but you have a whole square, but we can write this as a squared minus a squared, here is ia, so I will be getting one negative sign, so this will become plus, so it is a squared the whole square. So now there is no I in the denominator, and this I can separate the real and imaginary part. So this I can write it as s squared minus a squared by s squared plus a squared the whole square plus I into 2as by s squared plus a squared the whole square. So now I have a real part, I have an imaginary part. Now let me compare this and this. So comparing the real and imaginary parts. Imaginary parts. So what is the real part here? It is t into cos 80. And what is imaginary part? T into sin 80. So therefore L of t into cos 80, the real part, is equal to, the real part over here is s squared minus a squared by s squared plus a squared the whole square, and the imaginary part here is sin t into sin 80. So I can write that L of t into sin 80, and here the imaginary part is 2as by s squared plus a squared the whole square. So hence the proof. L of e power 4t sin 2t cos t. So this is sine and cos combination. So we have a trigonometric formula for this. What is sine cos formula? 1 by 2 sine of, if it is sine x cos y, it is 1 by 2 sine of x plus y plus sine of x minus y. So I am going to use that. This is equal to L of e power 4t. It is sine of x plus y. So x here is 2t, y here is t, plus sine of x minus y. So it is 2t minus t by 2. So this 1 by 2 I can take it outside. It is L of, take it in common, L of the first term will be e power 4t sine 2t plus t, it is sine 3t plus L of e power 4t sine t. So here also if you want you can use the direct formula for exponential into sine, or you can use the first shifting theorem. Let me use the direct formula here. So for sine it is b by s minus a the whole square plus b squared. So b here is 3 by s minus a here is 4 the whole square plus b squared, again it is 3 squared, plus b here is 1 by s minus a is 4 whole square plus 1 square. You can, if you want, you can write one more step. 3 by s minus 4 the whole square plus 9 plus 1 by s minus 4 the whole square plus 1. So this will be the answer.